Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. In the previous two lectures, we talked about the dummy variables. I will first start from the summary of the dummy variable, and then we will keep on enlarging our discussion about the similar issues. Similar means it is related to the nominal scale variable, although it will not, we will be using dummy variable in a different kind. So what were the dummy variables? Simply speaking, most of the time in our course we talked about the ratio scale variables. Dummy variables are only the categorical variable that shows that there are how many categories for a, you can say, specific group. For example, if I like to talk about the gender, there are two categories, male and female. If I am going to talk about some other categories, there may be more than two categories. So how to introduce these variables into the regression, because our previous discussion was that our dependent as well as the independent variable both for the ratio scale variable. Now we are talking about that if at the independent side our variable become dummy variable, or you can say the ratio scale variable, then nominal scale variable, then how to introduce them into the regression model. So what was the we designed the formula for this. We said that we can construct the dummy variables and we call them 0 and 1. 0 means the category is not present, and 1 means the category is present. This is the traditional view. You can change vice versa. Similarly, 0 and 1 are not necessarily only two, you can say, figure to whom for whom we can represent the dummy variable. There are, you can use 20 and 30 as well as any other two figures for the present as well as the absent of the categories. The most critical discussion was that there is a dummy variable trap. What this means, that we should introduce m-1 dummies into the model. What this means, that if there are 3 categories, we will be using only two dummy variables, and if there are 10 categories of a variable, then we will be introducing 9 dummy variable. What this means, the omitted category automatically becomes the benchmark category. The immediate question comes that which should be the benchmark, or you can say the base category. It is up to the researcher whichever category he selects for the analysis as a base category. After this, we studies that if there are the other choice is that we introduced as many dummies as there are the categories, but at the same time we should exclude the intercept, otherwise we will be falling in the dummy variable trap. And if you will be giving command to your eViews, you will not be finding the result if you are using as many dummies as there are the categories, and you also include the intercept. So what is the solution here using dummy variable? Simply use n-1 category, n-1 dummy variable, and the other is that exclude the intercept and use as many dummies as there are the categories. This was up to discussion, and we call one of the kind of the regression model that are the ANOVA model. ANOVA model says that on the independent side, our all variables are now nominal scale variable. They are categorical variable, and the model is said to be ANOVA model. But this is not the situation all the time. It may happen, but what is the reality? The ratio as well as the nominal or the categorical variable, they affect our dependent variable. So we can include the ratio scale variable as well as the nominal scale variable as independent, or you can say the regressor, and we can estimate to see their effect on our dependent variable. If this is the situation, that on the right side there is a mixture of ratio scale and the nominal scale variable, then our model is called ANCOVA model. So dummy variables are used in many different ways, and these are very critical because nowadays the categories of different variables, for example, the rich and the poor, you can say the educated, non-educated, you can say the black and white, whatsoever the categories are, they have nowadays, we want to capture their effect on the dependent variable. The one other advantage of the dummy variable is that it has potential to identify the breakage. If there is a breakage in the curve, or you can say the function, then we can use the piecewise linear regression model. That is another kind of the dummy variable. After this, now we will continue our discussion about that what happens if dependent variable is dummy variable. Now another regime is starting, and it is a very, very interesting regime, particularly for those persons who are interested in the situation when they conduct survey and they come to know that their dependent variable is a categorical or the dummy variable. So this is very interesting situation. At the same time, it is very easy and interesting, and on the other side, it possesses some of the fundamental, you can say, the threats to our estimation process, that is the ordinary least square method. So what this means, we will be looking for some other methodology to estimate the parameters that are the, you can say, the intercept and the slope coefficients. So what is this? In all the regression models that we considered by now, what was assumed that the regressant, the dependent variable or the response variable y is quantitative. Every time we talked about the independent variable, but the situation we implicitly assume that our dependent variable, that is the regressant, that is the we assume that this is a ratio scale variable, but it is not necessarily true that it is always a ratio scale variable. It may be dummy variable, and from today we will start discussion. And the variable y is quantitative, where the explanatory variables are either quantitative, qualitative, or dummyable, or a mixture of them. So now our total focus is on the dependent variable. In the previous 26 lecture, we continuously focused the independent variable. Now we are shifting our whole concentration towards the dependent variable, and at the outset we are clearing that we have nothing to do with the independent variable. Now they could be only ratio scale variable, they could be only nominal scale variable, and at the same time there may be the mixture of ratio scale as well as the nominal scale variable. But our concern is now only that our dependent variable, that is y, it is not now ratio scale variable, it has also become a dummy variable, and we will see that how we progress this. Although increasingly used, these models are increasingly used in various areas of social sciences. All the social sciences are using this kind of regression model. Qualitative response model regression pose interesting estimation and interpretation challenges. This is very interesting, that although all the sciences with varying degree are getting help from these regression model, and but at the same time the interpretation, and there is a threat to our estimator. So we will have to overcome these problems, and because these are very necessary, and we will continue that how we can control. These are manageable problems. You can't say that now the situation is coming out of control. These problems are surmountable, and definitely we will come up with some of the concrete, solid, and important solutions. What happens if the dependent variable is a dummy variable? Interestingly, regressant can be qualitative or dummy decision to participate in the labor force. This is our first example. For example, if we conduct a survey on you people and we want to see that whether you want to be included in the labor force or no. So our response now our dependent variable, we are going to examine your behavior, that whether you are going to one category, that is the labor force, or you are still wanted to go out of this labor force category. So look at this, our dependent variable has become a categorical variable, a dummy variable, and there are only two responses, that is the yes or the no. So we have to now progress on the same footing. And at the same time, that if this is the situation, can we still use OLS? OLS is, I know, your favorite formula, or you can say the mechanism, because we always talked about OLS, ordinary least square method. Now we have to see that whether it is still helpful for us, and if it is okay, then we will be very happy, and if it is not the case, we should have to go for some of other solution. Statistical, there are several statistical problems that one faces in such model. Many mechanically, look at here the sentence, yes, mechanically we can do so. We take the regression, we apply OLS on the model, it will estimate our parameters. No need to worry about it, but this will be mechanics. Why this will be mechanic? The dependent variable, that is the very sensitive, to whom we are giving extraordinary respect, because our ultimate purpose is to predict the average value, or you can see the mean value of the dependent variable. That's why everything is hovering around the dependent variable, and we are taking extraordinary care about the dependent variable. There are, when we apply the OLS, mechanically apply, there are several statistical problems. You know the statistical problem, statistics and the mathematics are only tools. They have nothing to do, they just help you to conduct your analysis. So we will see that sometime statistic will say that the normality assumption is not fulfilled, sometimes the other case, and we will see that which problem may occur when we are using the ordinary least square method. Fortunately, there are alternative to OLS. If there are, now we have said that there is a problem for the OLS, there are alternative. And if there were no alternative, then what would have happened? Fortunately, need not to worry, there are alternative. That faces these problems. The problem that OLS faces, they will be solved by some other method. So before going further, I would like to give some of, you can say, the terminology dichotomous dependent variable. Dichotomous means that our dependent variable has only two categories, yes or no, presence or absence, and whatsoever, and this is called the binary variable as well as the dichotomous variable. There are number of examples. For example, if I see that gender, this is male and female, your behavior yes or no, in the if we go to the United States and see to which party the people are wanted to give vote, Republican, or you can say the Democrats, two parties, two categories. So when there are only two categories for the dummy variable, that is now our dependent variable, we call it the dichotomous variable. Trichotomous and polychotomous variable, there are some other cases. Trichotomous means now there are three categories. Rather than two categories, there are now three categories. For example, if I say, I ask from you that whether you are going by cycle, motorcycle or car, in this situation there are now three options. Similarly, we can say strong, very strong or poor. So in this case there are three categories, and these are called the trichotomous variable. And unfortunately, it is not restricted to three variables. There may be more than three categories, and we will be calling them that they are polychotomous dependent variable, where dependent variable have more than two categories. Rather than more than one categories, they are polychotomous variable. We call them the trichotomous, and so on, going and going. So if I would like to give example, for example, now how to this, look at this, for example, Y, now this is, you can say, the behavior of a voter to see that whether he is going to give vote to the A party or B party. It could be beta 1 plus beta 2 x2 plus beta 3 x3. Now we are nothing to do with these variables. You can suppose that these independent variable can assume any of the situation. They may be ordinal scale variable, they may be ratio scale variable, or at the same time you can say they are nominal scale variable. Our concern is, look at here, when there are only two parties, do not still take the case of Pakistan. It will fall into the category of the polycotomous dependent variable. I will be coming back to this situation. So in USA, if you go to a person and you ask in which party you are going to, so there are two parties, the Democrats and the Republican. So there are two categories, and our dependent variable now Y has binary variable. Similarly, now apply the same situation to Pakistan. Now you can, starting from PPP, PTI, PML, and there are N and Q. I am not going to this. And there is Jamaat-e-Islami and so many other. So look at there, if we ask a person in Pakistan to whom he is going to give vote, then you will be looking that your dependent variable has become polycotomous variable rather than the binary or the, you can say, the trichotomous variable. Now we are just going further insight into the nature of the qualitative response model. The variables, before going further, I would like to give that what are the qualitative response models? The model in which the dependent variable is a dummy variable. Now if I call it a dummy variable, categorical variable, the same thing, or even I can say that these are the nominal scale variable. So what are the qualitative? The previous model were quantitative response model. Your dependent variable was a quantifiable variable, but unfortunately, but at the same time, interestingly, now we are entering into the domain that is a very vast domain and very, you can say, the important from the current view, because nowadays we are looking, now you are looking the surveys on GeoTVs and whatsoever, they are looking and asking from the people to which party they are choosing for vote, and you are looking, they are telling you that how many percent people say that they are going to vote that party or that party. So qualitative response variable models are the variables in the way in which the dependent variable is a, you can say, the categorical variable. Suppose we want to study the labor force participation decision of adult males. That there are males, definitely we will be talking about the adult males. Why? Because we are not concerned about the child labor. So what we will ask from them, we will ask them that whether they are in or out of the labor force. Similarly, now your response variables are in or out, or you can say yes or no. So this is a yes or no decision. Go further, hence the response variable or regression can take only two values, say one for if the person is in the labor force or is not. In this category, again the same situation, the binary variable, that this can be when you are asking from the people that whether they are in the labor force category or not, they can, you can see, only give two answers. Yeah, are they the part of the labor force or they are still out of the labor force? So it is up to you. For example, if you say that if they say yes, you code it 1. The coding is necessary because now we will be using the dummy variable, and unless and until we code this, we are unable to see that what is the effect of this. In other words, the regression is binary. No need to explain. Or dichotomous, the same thing. Labor economics research suggests that the labor force participation decision is a function of unemployment rate, average wage rate, education, family income. Now these, the last line from here to here, these are independent variable. we have nothing to do with now. I will not explain it. I have just given you a glimpse. You can include as many independent variables that can affect the behavior of the people to decide whether to participate in the labor force or not. I have no concern here. Other example, what could be the other example of binary variable is that I ask from you whether you own a house or not. So our dependent variable, this is and beta 1 plus beta 2 x. So can I say that this is x is simply, you can say, the income, and y is that you own a house or you do not own or do not. So what this means, if you own a house, I will say it 1, and if you do not own a house, I will use the dummy variable, that is the 0. So the next is that what we shall learn in this situation, although we will be covering many of the areas, but still it is not necessary that we will be going deeper and deeper into this. So I am giving you some of the glimpse, and you can say I am setting the boundary lines in which we will be running, and we will not be crossing this. So first of all is, how do we estimate qualitative response regression model? Again, bringing your attention to just 2 or 3 slides before that, now OLS becomes questionable because there is some statistical problem, no mechanics involved there. Mechanically you can do this, but at the same time now it becomes, you can say, the problematic. And can we will impose the question that can we simply estimate with usual OLS procedure? One thing you will say yes, and you will say mechanically it is possible mechanically, but no, it poses different threats that are, you can say, that are the in a statistical inference, or what are the special inference problem. Yes, are there any special inference problem? So first of all, now you will be guessing that I am going towards to show the problem of the OLS procedure, that what problem it can face, because if it is problematic we will be discarding it and then we will be going for the other method. If we are unable to detect that what are the problem with your favorite OLS method, then you will be questioning that why we need to go for some of the other method. So what is this? In other words, the hypothesis testing procedure any different from the ones we have learned so far? The next question is that is there any effect on our hypothesis procedure? This is, you can say, a very, very critical question, that if there is any change in our confidence interval, if we apply the OLS, estimate the parameter, and we see that there is a problem in constructing our confidence interval, we will come to know that this is there is a hypothesis problem, and I think it will be overemphasized if I explain that what is, you can say, the problem of confidence interval. If regression is qualitative, how can we measure the goodness of it? Another hit on your previous, you can say, the previous knowledge, that now the R square, that is the coefficient of determination, that tells us that how much variation in the dependent variable has been explained by the independent variable, it also becomes questionable. So it means when the dependent variable is qualitative, then there are many problems, and first the problem was OLS is now limbering. So it is not showing, it may show some of the incorrect. The other is that the goodness of it creates some of the problem. And the next question will be, is the conventionally R square have any value more? We will see. I will not give any comment here. We will first prove and then we will deduce some of the problem. And the next question we will see that once we go beyond the dichotomous regression case, binary, okay, then if we cross this limit that our dependent variable has more than 2 categories, how do we estimate and interpret the polycotomous regression model. So this is the boundary line. In other way, you can say these are the rules and regulation about our discussion for this lecture, and the lecture that will be after this, it means that will be the 28th lecture. So in this area we will be trying to answer these questions, and you will see that hopefully we are in a position to answer these questions. There are three approaches to develop probability model for a binary response model. Now immediately you have come to know that a new word has entered into this domain, and that is the probability. In the previous, we were not using, in the previous model, regression model, we were not using the probability. Now the probability concept enters in the domain, because now there is probability, either you own a house or you do not own a house. Similarly, there is the probability that you are part of the labor force or you are out of the labor force. Although there is 0 and 1 probability, if you are part of the labor force, we will say the probability is 1, and if you are not the part of the labor force, the probability is 0. However, whatsoever the situation, the probability has appeared in our model. The first model we can use for this, these are called the linear probability model, LPM, linear probability model. The more important thing is that the linear, and we will be discussing it detail. At this time it is enough to just remember the name of this. After this we will be going for the logit model, and after that we will be going for the probit model. And we will not stop our discussion up to here. We may go for the ordinal, logit and probit, and similarly Tobit model, and one other, the multinomial logit or probit. You will be thinking that there are so many models to estimate these regression or qualitative response regression models. These are very simple. If you learn about one of the method, the others are only the extension, and there is this very small difference that is, you can say, you can capture when you try on this. And before going further, I will strict here that I will be avoiding the maximum possible use of the mathematics, and I would like to give you some of the insight, the crux, the ideas, and the theory that lies behind this. The ultimate responsibility will be on your shoulder. You can consult any of the recommended book. You can go for the software, and this can help you a lot. First, considering the LPM, what is this? Linear probability model. Consider this model. This model is before you. I wrote this model 1 or 2 slides before, so this is not new to you. We are talking about the family income. This XI is family income. So what I assuming, I am talking about you who are listening me on the laptop, that I am talking about your family. So what is this? X is your income, and you can see Y is that whether you have a house, a home, or you do not own a house. And I will be happy if you own a house, and hopefully you, and if you do not have the home, so we will be just considering the probability. We are not allotting any home to any person if he doesn't have a home or he is living in a rental house. The model, what this means, that Y is equal to 1. Now again I will be clear that Y is only binary response variable, whether you own a house or not. If Y is equal to 1, it means you are living in your own house. Living means you have your own house. And if it is equal to 0, it means that you do not own a house. You are living on rental or some of the other arrangement there. If you look at the model, this is very simple. It looks like typical linear regression model. As comparatively we saw there. So what will be immediately the situation emerges, that we should apply the OLS if this is the situation that it is similar to the previous. But you will see, because the regression is binary or dichotomous, it is called a linear probability model. So now what this means, what is the difference from this model and the previous model? In physical appearance, it looks the same model as we did previously. But now what is the difference? Your response or the dependent variable, it has become, you can say, that the dichotomous variable, and now it is called the linear probability model. The discussion continues about the linear probability model. Now we are further going, what we will be writing, that the conditional expectation of yi xi. So what is this? And you are you can easily write expected value of yi given xi. You can do this, can be interpreted as the conditional probability. In the previous example, we used to say that as the independent variable increases by 1 unit, there is on average increase such and such situation. But what is this? Now these dependent variable can be interpreted as the conditional probability. It is based on some of the probability. The event will occur given xi, that is probability of y is equal to 1 given xi. For example, it will, if you own a house, this will become expected. If I am calculating the probability of a person who is owning a house, so yi is equal to 1. 1 you have selected by the presence of the, you can say, that you own a house, and this is the xi, given xi, that is the conditional probability. Thus it gives the probability, expected value of y gives the probability of a family owning a house and whose income is the given amount of x. Xi will be changing. For example, if xi is the people who have monthly income of 50,000, the monthly income have 1 lakh, monthly income have 5 lakh. So this will change, but we are looking on the two probabilities. The first is whether this family own a house. Now there is a probability, chance it owns or it doesn't own, the probability may be 0 or 1. On the other hand, if I write this one, this can be written in another way, that now expected value of yi is equal to 0. The families do not own the house given xi. This is the situation. The conditional if you look at this, the probability, this is now, you can see the probability. And I will be, you can say, try to remember you the probability concept, that the probability never crosses two limits. It ranges between 0 less than equal to, this is the probability, and 1. The probability of any event could be minimum 0 and maximum 1, and it ranges within this range. So if our you can see, this is the probability that you do not own a house, and 1 is the probability you own a house. Similarly, if our binary variable is that if a person is male or female, if I suppose that if he is male, the probability is 1, and if she is male, the probability is 0. 0 and 1 is up to you. It is not necessarily that what I am saying, it should be taken as that something sacred, and every time you will be using 0 for the same purpose and 1 for the other. You should be able to capture the idea that these are only notation, and these are, you can say, changeable according to different scenario. So what is this? If the probability of owning a house is pi, the probability of not owning a house 1 minus pi. Because this is the binary variable, so what will be this? And their total should be equal to 1. So what is this? Probability of owning a house, this is pi, and not owning a house, it is 1 minus pi. And the total probability, if you see that the total probability is equal to pi plus 1 minus pi, and this will cancel out with this, so the total is 1, that you can easily see that the total is 1. So the total of simple probability is always, you sum up to 1, or you can say the 100. And if you look at here, that we have set a range. We have not set, this is a rule of the probability, that the expected value of yi given xi. So yi is the probability of owning a house. It can range between 0 and 1. If it is 0, you are homeless. If it is 1, you are owner of a house. What is the advantage of LPM? That is the linear probability model. After this, I am not forgetting that I have to tell you that what the problems it faces when we are using the OLS, ordinary least square method. So what is the interpretation is straightforward. One of the advantage of the linear probability model is that its interpretation is simple and it is almost similar to the previous one. The coefficient is interpreted in the same way. I will suppose some of the coefficient and I will explain, and you will come to know that the interpretation in the linear probability model is not significantly different from the other. The same way as the coefficient is interpreted in the same way as linear regression. And you know what was, how we explained this. For example, if the predicted probability of owning a house, for example, what is this? I say that the expected probability of yi when it is equal to 1 owning a house given xi. So what is this? If, for example, I get this beta 2. For example, this was our previous model. Yi is equal to beta 1 plus beta 2 xi plus ui. So what this mean? Yi is equal to, for example, this is 10 plus 0.4 xi. So now our purpose is to explain that beta 2 is now 0.4. So what this means, that if beta 2 is equal to, then the predicted probability, now we will be talking in the terms of probability, the predicted probability of owning a home increases by 0.4 holding all other variable constant. Increase means there is a positive sign. If there would have been negative sign, I have asked that it decreases. Keep in mind that for the only simplicity problem, every time we are using the plus sign because it avoids many of the complication. Otherwise, there is no something special behind this. So I would like to repeat it again. For example, if you get 0.4, what you will explain? The probability of owning a home increases by 0.4. In other way, I would like to say, ignoring minus and plus, it changes by 0.4, holding all other variable constant. Because when we are explaining the only targeted variable effect, and we are assuming that all the other variables have, you can say, they have been held constant. Now the problem of the LPM linear probability model start. First is that non-normality of the disturbance ui. This is the first thing, that in this case that our ui, that is the error term, it is not normally distributed. And if you stress your memory, you will be looking that we did not make any assumption in the case of OLS. So what is necessary to explain this here? You will see that although OLS does not require the disturbance to be normally distributed, OLS doesn't assume that this is for statistical reason, not for the OLS reason. For statistical inference, they are assumed to be so distributed. It is not the, you can say, the assumption of the OLS that the error term should be normal distribution. It is for our own statistical inference simplicity, we assume that they should be normally distribution. But the assumption of normality of error term to be normal distribution is not tenable, because now it is not tenable. Now it is not comprehensible. Why? Like yi, that is your probability now the disturbance ui also take only two values. When your dependent variable is taking only two values of 0 and 1, your ui also takes two values and they also follow the Bernoulli distribution. I am not going to explain that what is the Bernoulli distribution. You can guess from here that the Bernoulli distribution is saying something that the variable is just can change between the two variables. So first problem with the OLS estimation is that our residual terms are not normally distribution. Although it is not the assumption of the OLS, but still we say that for statistical reasons and simplicity we assume that this is normally distribution. And if you see that now this assumption is not easy to comprehend, because if your dependent variable only changes between two of the restricted values, your error term is also bound to change between assume two values, and this has been explained by the Bernoulli distribution. I have explained the T distribution, the Z distribution. If you are interested that what are the Bernoulli distribution, you can go for any of the source. Linear probability models, the continuous equation. One problem we have discussed. What is the problem? No, you are not sitting before me, but you are telling me, I can listen you that you are telling that the residuals are not normally distribution. The other problem is heteroscedastic variance of the disturbance. Now again you will be looking that I am going towards this previous discussion. No, I am not going to open a box that becomes uncontrollable. I will only like to say that now the variance of the error term is not homoscedastic, it has become heteroscedastic. What is this? Even it is heteroscedastic, if you look at here, that if expected value of ui is equal to 0, we assume that covariance between uj is equal to 0, it means there is no serial autocorrelation. It still, we can't maintain that the LPM disturbance are homoscedastic. होना तो ये चाहिए कि जब ये दो assumption पूरे हो रहे हैं, this is the first one and this is the second one, that no autocorrelation and the residuals are normal distribution, what should be the result? That the result should be that the variance should be homoscedastic. But still in the LPM, linear probability model, it is still not fulfilling this criteria. What will happen? Error term will tend to be larger for the middle values of the x. So for this, you can say, to prove this claim, that we need some of the mathematics. I am not going to this. You have to remember that the error term variance becomes larger for the central values of the x. OLS, when there is variance of the error term, definitely there is a problem. OLS estimates are inefficient and standard error are biased. Lo ji, masla hi kharab ho gaya. Again the problem is there. Inefficient means they have not now minimum variance, and biased that their expected value of their mean will not converge to the true beta. We are not concerned about that. What is this? We are concerned about the problem. That what problem could occur? The problem of hypothesis testing could occur. Why this occur? Because now variances are high, and as the variances are high, you can immediately guess the confidence interval becomes wider and wider. The acceptance region of the null hypothesis increasing, and there is the probability, there are the more chances that you are going to accept the null hypothesis rather than rejecting the null hypothesis. This was the second problem with the OLS estimator. Non-fulfillment of 0, we assumed that our yi variable will be in following between 0 and 1. It is definitely probability cannot go from this 0 and 1, cannot cross these limits, cannot go beyond these, you can say, the boundaries. But unfortunately, when you will estimate, the OLS estimator may give the values that are less than 0 or greater than 1. So what this means, that it is crossing the limits. So we will be looking at this. So what is this? The predicted value 0 or you can say less than 0, minus में जा सकती हैं, and greater than 1. So it is against our this situation where we said that the probabilities are only can range between 0 and 1. This is the real problem. The previous two problems are not equally, you can say, the less important, but this is a huge threat that it has changed the total phenomena, that the probabilities are, you can say, the estimated or the predicted y. Y is what now? Probability of owning or not owning a house. Only concentrating on only one our example, you can take any of the example. So this is the real problem of the OLS estimation. So we will just concentrate a bit while on this, and then we will go for the next problem. This is the third problem, that the non-fulfillment of the area we have said 0 and 1. How we come to know that the OLS estimator has crossed the limit 0 and 1? What is this? Simply estimate the LPM, linear probability model, by usual OLS, and find out whether the estimated y lie between 0 and 1. The what is simple desi and domestic method, construct the LPM model, simply the linear regression model, and then what you will be doing, you will be applying the OLS, and you will see that the whether yi hat, that is the now the expected value, either it is within the range of 0 and 1 or it is crossing the limit, and what is, if they are greater than 1, they are assumed to be 1. If they cross the limit of 1, they become greater than 1, we say no, they are equal to 1. It is a method, you can say, the value, because it cannot cross the 1, it will cross the in estimation, but we have now, you can say, the cutting of this our edge, and we are, if it is outside, we will bring it back and we will say it is equal to 1. If they are assumed to be 1. The second is, and if they are less than 0, they are assumed to be 0. The second procedure is devise an estimating technique that will guarantee that the estimated conditional probability will lie between 0 and 1. Pehla to tarika, that is very simple, that do it, and if you think that it is 0 and 1, greater than 1 and less than 0, assume that it is equal to 0 and equal to 1. The second, that is the more attractive and the logical, that rather than sticking on the OLS or the linear probability model, why we should not go for some of the other solution? If the other solution guarantees us that our values, estimated values, will not cross the limits of 0 and 1, then we will be looking at this, and shortly you will be looking that to whom I am going to address. The Logit and Probit model. Immediate contender have emerged. The Logit and the Probit model guarantee. LPM doesn't guarantee. Linear probability model doesn't guarantee, but the Logit and Probit model, they guarantee that the estimated probabilities will be indeed between the logical limits 0 and 1. So what we are going to use? Now I know you are not using the linear probability model, you are using the Logit and Probit model, because they will give you the guarantee that now your expected value, or you can say the estimated values, will not cross the limits of 0 and 1 that you have set. The fourth problem, I will at the end I will count that what were the problem. The fourth problem is R square becomes questionable. We are worried every time that now another ek naya syapa shuru ho gaya. So this is not the syapa, this is the refinement of the theory. So more and more you have learned about this, the more and more you are competent. So I would like to make you that at any stage you can defend each and everything regarding your thesis. So fourth is the R square becomes questionable. If it becomes questionable, what is this? The conditionally computed R square, definitely when you will run the regression, there will be R square, is of limited value in the dichotomous response model. So I will cross this. When there are dichotomous or qualitative response model where your dependent variable is binary, you should not concentrate on the R square. What is this? Whether now you will be thinking that whether it gives higher value or lower values. Look at this. The conventionally computed R square is likely to be much lower than 1 for such model. It is, you can say, the suppressing. The reality is higher, but R square is not telling us that it is exact reality, it is less than. What this means? It is deflating our information, so we have to avoid this. In most practical application, the R square ranges between 0 to 0.6. Do not think that I am talking about the conventional R square. Conventional R square ranges between 0 to 1. If a 0, it means the model is not explaining any of the variation in the dependent variable. If it is 1, full, your model is very good. But in linear probability model, when we estimate again and again on different data, the people have come to know that most of the time R square remains between two limits, 0.2 and 0.6. 0.6 is the highest and 0.2 is the lowest. What this means, we are concerned about the highest because we have said that in this case it is much less than the 1. So what this means, the maximum our model can explain 60% of the variation of the dependent variable. So it means it has been being suppressed of some of the things. So but look at this, this was the empirical analysis, but in reality what happened in such models will be high, say in excess. ये रहेगा तो 0.2 and 0.6 के दरमियान, but still in reality it is 0.8. What this means? 80% variation is explained, but your R square in the linear probability model is now showing that there is variation is being explained only 0.6. So what is this? Therefore, the use of the coefficient of determination, that is the R square, as a summary statistics, you know it is our summary statistic, should be avoided. So this is solution for you. Now you should not concentrate on this in model with qualitative dependent variable. Now clear and general rule. What is the rule? That when your dependent variable is a qualitative response variable, you should not depend on the coefficient of determination, that is the R square. Now look at some of the situation. These are the model here. Look at this. This is the LPM linear probability model, and you can say it is crossing the limit. This is the maximum probability 1, this is the 0, and you can say from here this is limit is beyond and this is less than 0. So the unconstrained, you can say we do not put constraint on it, it may cross the limit of this, and you can say it can assume only two values, that is the 1 and at each value of x. For example, when x is this situation, y is 0 here, and when x is here, x is this situation, that are the, you can say the dotted points, it could be 1. On the right hand side, you should come that now the same, we have estimated the same LPM, but now we have put some restriction on it and it has become S-shaped distribution. So what this means, from here it was crossing, and it was crossing the limit, making problem for us, and at the same time it was crossing this limit 0, and you know our limit is 0 to 1, not less than 0, not greater than 1. So what we did, we put some of the restriction on this. So now Bechara, now it is bound to be within the limit. Now you can say that now it is changing its trends here, and it is also changing in trends here. So what is the real situation? Look at this. LPM will be well explained if these are the point, this is the B point, say these. If X values are more concentrated on A and B, then it will be giving you a good picture, or you can say the higher R square. So this was some of the, you can say, scenario of this. Alternative to linear probability models. What could be, we are talking about the, what could be the you can say the alternate. For example, now we have rejected the LPM, linear probability model. We said no, it is not much concern to us. So what is the solution? Now I would like to again, you can say, remember, this was the problem with the LPM, that our residual were not normally distribution, that your expected value of UI, what this means, this was expected value of UI is not equal to 0, not normally distribution. What is this? That this is heteroscedasticity, expected value of UI hat square is not sigma square, but it is homostatic. Possibility of y hat lying outside the 0 and 1 range. This was the third problem with the LPM. And the last was that the generally lower R square values. So these are the 4 problems. So now it means the linear probability model has become a bit, you can say, the less important, and now we have to go for some of the other solution. So what is this? These problems are surmountable. What this means, these are controllable. All the 4 problems you can control. For example, start from here. WLS. What is WLS? Think, think and think. This is the weighted least square. You remember, and I don't think that you have forgotten about this. So WLS can resolve the heteroscedasticity problem. आपका ये मसला, immediately apply the WLS weighted least square. If you remember, in the case of heteroscedasticity, when we were showing the remedial measure, we came to know that WLS, that is the weighted least square estimate or method, this has the potential to address this issue. We can increase the sample size to minimize the non-normality problem. There is this normality problem, that is, this is not normally distribution, not normally distributed. To avoid this problem, distributed. पहले एक प्रॉब्लम पर आपने जो है वो कोशिश की प्रॉब्लम कंट्रोल करने की, that if error is error variance is changing, you can apply the WLS, still LPM is valid. And if your UI are not normally distributed, one tricky way to increase your sample size, and ultimately over time it may be normally distributed. So it means we can address this problem. But even then, the fundamental problem with the linear probability is not logically a very attractive model. So now you will be thinking that I am biased against the LPM. I am not biased against the LPM. The theory says that although we can control many of the problem of LPM, but still it is not attractive method. Why it is not attractive? Because it assumes that the probability increases linearly with xi. This is the weak assumption, that what this linear probability model assumes, that the probability or the expected value of yi given xi, it increases linearly with the xi. What this means? This means that the marginal or incremental effect of x remains constant throughout. That every time the marginal, if you have some concern about the marginal theory, you come to know that the marginal is not always the same. It is changing over time. So if this model is assuming that the dependent variable's probability is linearly related with the values of the independent variable, so this is a very critical and difficult to digest this assumption, because indirectly it means that the marginal effect, or you can say the marginal or incremental effect of x remains constant throughout. This seems patently unrealistic. this we will see that this assumption becomes totally unrealistic. And if it is unrealistic, in reality one would expect that the pi is non-linearly related to x. By assumption it is okay that this is linearly related to this, but in reality we will come to know that this is not the situation. So if this is not the situation, so it means despite many of the problem of the linear probability model can be overcome, but still we will say that it is not, you can say, the good example of this. So what is this means? Rather than going further, I would like to give you the summary, and I will continue discussion in the next lecture about the models that have qualitative response model as a dependent variable. If you remember, today we started our discussion about the qualitative response model. What is these model? Simply speaking, that when your dependent variable becomes a categorical or a dummy variable, these models are called the qualitative response model. Now, for the time being, throw into the hell the independent variable. Only talk about your dependent variable. So if our dependent variable have only two categories, you can now give as many examples as you can, but I would like to again go only two, that if there are only two parties, that Pakistan Muslim League and the Pakistan People's Party, and you ask from a person to whom you are going to give vote, that there are two categories. When your dependent variable have two categories, it is called the bicotomous or the binary variable. And if it has three categories, for example, I bring one more party into the scene, that is, you can say, the PTI, and now if you ask the same voter, now it has three options, so now our dependent variable has become trichotomous. And even if there are more than these categories, as is nowadays a very good example of this election, that in Pakistan there are, I think, more than 20 registered parties. It is my very, very careful guess, it may go up even up to 50. So what this means, that there are more, if you will asking from the same person to which party he is going to select for voting, you will see that now the options are more than two and the model has become trichotomous. So if this is the situation, then the problem of estimation arises. Why it arises? We can't use the OLS. In physical appearance, the model looks like the linear regression model, but at the same time you can see that there are potential threats about estimating this. What were the potential threat? The major threat was that the assumption of normally distribution of the error term is lapsed. It is, although it is not the assumption of the OLS, but it is for the statistical reason, and if you are not assuming this, we may have some of the problem. So the first model we used in this kind was the linear probability model. I just explained one of the problem of the linear probability model. In linear probability model, we assume that we will be hitting at the later sentences of this summary, that the linear probability model assume that the probability of the dependent variable is linearly related with the values of the independent variable. So linear probability model in bivariate model that we have discussed by now, it can assume only two values. Its probability is 0 if you do not own a house, its probability is 1 if you own a house. So the probability can run into only two values, that is the 0 and the 1, and if it can't cross this. But the problem of the linear probability model is that when you estimate it by OLS, there is the possibility that it is crossing the limit. What this means, it may go up to 1, it may drop below the 0. So if this is the situation, you can discard the values that are greater than 1 and you can assume that these are equal to 1, and the values that are below the 0, you can say that these are equal to 0. The next problem for this could be that the variance of the error term is not equal, and you are well aware of this, that if the variance of the error term is not equal constant, there is the problem of hypothesis testing. And if you remember, that the other problem for this was that the R square, the generally R square is not valuable. The value of the R square becomes lower as compared to the conventional R square. So it means it has been indirectly suppressed by some of the power, that it is not showing the real values. And interestingly, the researcher has come up with the you can say the conclusion that most of the time it remains between 0.2 or 0.6. In other words, I can say it says it remains between 20% and 60%. When its reality is that when it is equal to 80%. So it means almost it is not showing the 80% information, it is hiding the 20% variation. These problems, these four problems are controllable. What is the first? That the normality assumption can be overcome, that if you increase the your sample size very large. And if you the heteroscedastic problem of the variance, it can be overcome that when we use the weighted least square method. So, but at the same times, if all this is done, one problem remains there that is very difficult to digest, not only for you but for everyone including me, that the linear probability model LPM assumes that the probability of the dichotomous variable or the qualitative response variable is linked with the values of the independent variable in a linear way. This is a bit, you can say, difficult to digest. So I would like to conclude here. See you in the next lecture. Goodbye and Allah Hafiz.